This video is about how to solve linear first-order ordinary differential equations. And a linear first-order differential equation is of the form y prime plus p sub xy equals q sub x. Here are the steps. Number 1, write the equation in the proper form. Write the equation in the proper form. So that proper form is y prime plus p sub xy equals q sub x. Now you may be wondering, why is this a first step? So let's say we have this situation. You're asked to solve the equation dy dx equals 19.8 minus 0.3y. Does this form right now match the proper form of a linear first-order ordinary differential equation? No. So how do we rewrite this? First of all, y prime is equal to dy dx, so we can make that substitution. And second, we can move the negative 0.3y from the right side to the left side by adding 0.3y to both sides. And that gives us this equation, y prime plus 0.3y equals 19.8, and that is in the form y prime plus p sub x times y equals q sub x. Now to answer that question, why is it important to have the equation written in the proper form? So that we can identify the correct functions p sub x and q sub x to use in later steps to obtain the general solution of this differential equation. Step number 2, identify p sub x and q sub x. Identify p sub x and q sub x. So from step 1, our equation was y prime plus 0.3y equals 19.8. And let's write the proper form of a first-order linear ordinary differential equation below this, and we find that that's y prime plus p sub xy equals q sub x. So p sub x is whatever constant or function is multiplied times the y variable. So p sub x here is 0.3. Q sub x is whatever this equation is equal to on the right side. So q sub x equals 19.8. So p sub x is 0.3. Q sub x is 19.8. Step number 3. Find the integrating factor I sub x. Find the integrating factor I sub x. Now the integrating factor I sub x is equal to e to the power of the integral p sub x dx. And from our previous work, in step 2, we identified p sub x to be 0.3. So here, I sub x equals the integral, or e to the power of the integral p sub x dx, which would be e to the integral of 0.3 dx. The integral of 0.3 dx is just e to the 0.3x. So there's I sub x. Number 4, find the general solution. Find the general solution. Now, we need to recall that I sub x was e to the 0.3x, and q sub x was equal to 19.8. We will need to know these two functions in order to substitute them into the formula to find the general solution of this linear first order ordinary differential equation. And the formula that we use is I sub x times y equals parentheses the integral I sub x times q sub x dx plus c. Now we'll substitute in these values. I sub x is e to the 0.3x times y equal to the integral. Now the q sub x I'm going to write first because that's a constant. 19.8 times I sub x is e to the 0.3x dx plus c. Now let's simplify that integral. E to the negative 0.3x times y equals, well, this would be 19.8. Need to divide that by 0.3 times e to the 0.3x. Remember the integral of e to the x, you just get the same thing over again. I just need to divide it by that 0.3 so that it does not change that constant. And this will be plus c. Now we can simplify a little bit. 19.8 divided by 0.3 happens to be 66. E to the 0.3x plus c. Now to get y by itself, we divide all terms on both sides by e to the power 0.3x. So y is equal to 66 plus c e to the negative 0.3x. And there we go. This is the general solution of that first order ordinary linear differential equation. Please look for further videos where we will solve more challenging or difficult linear first order differential equations, and also learn how to solve initial value problems of linear first order ordinary differential equations. Thank you, and please like the video and hit that subscriber button. Thank you.